I'll finish this topic on shrinkage. There are many types of shrinkage. Some are of interest to people in the green concrete making stage. Building Technology Division deals with that. We are structural engineers. We deal with hardened concrete. We are concerned with shrinkage for many reasons. Primarily for 2-3 reasons. Why is shrinkage important for us designers? Shrinkage of concrete is important. Why?
Area will decrease.
Huh?
Area will decrease.
Not much. No. What is the shrinkage strain we are talking about? What's the percentage? The code itself says 0.003. That's so small. It's not significant. So why should we learn about it? In fact, it's good to ask this question in every subject that you learn. Of course, sometimes you can learn for the fun of it. That is a must. But it is necessary for us in practice to know about shrinkage. Why? First, in pre-stress concrete, you saw that you have a loss, and you must know how much you are losing. You are losing pre-stress over time, obvious. Then it can cause tensile stresses in members provided. Let me put it this way. You've got this pen, but it could be let's say a metal strip. Let's say you put it on a frictionless surface. You heat it or you cool it. It will change its dimension. Will it cause tension? Will it cause any stress?
No.
So, but you said it will cause stress.
If it's restrained.
Huh?
If it's restrained.
If it is restrained, only you have problems of tensile stress. But you can also get compressive stress. But there's a peculiar problem with reinforced concrete. What is that? Peculiar problem with reinforced concrete is concrete wants to shrink, steel doesn't want to shrink. Okay. Steel doesn't want to shrink, concrete wants to shrink. What kind of problems that brings up? Let's explore. So that's a peculiar issue. But more important, from serviceability point of view, why is it necessary to know about shrinkage? Shrinkage, you heard of deflection of beams or flexion members. Deflection can be short-term and long-term. Long-term is caused by effects of creep and shrinkage. So shrinkage causes deflection. We'll look at that later. So it's necessary to know about shrinkage. And there are specialized applications where it's important. Once we were involved with a project for ISRO, Indian Space Research Organization. This is some 15 years back. They had to set up a testing facility where they needed to take measurements using their telescopes, and they didn't want any change in movement. So it was carefully calibrated. But unfortunately, all their equipment has to be housed in a building and supported on concrete structures. So they had a projector and a place where the image was projected, and they wanted that distance constant. So I asked them, what's the tolerance you want? Tolerance they want is 1 micron. I said, I'm sorry, because your structure is sitting on a concrete pedestal. That pedestal is going to shrink. And that distance may get affected. we solved the problem. It was very interesting, very challenging. But there are all kinds of, so it depends on the level of accuracy. But shrinkage can cause problems. The next is, how do you analyze for shrinkage? We were supposed to only proof check the design, but we found the designers were making massive blunders. Someday I'll give you a talk on the errors that structural engineers make by simply using software they don't understand. Because they analyze the whole thing, foundation and all that, using, I think, what's that software called? I better not mention the name of the software. Software is not to blame. How you use it is important. So they took this pedestal with the raft foundation and all that, and they applied shrinkage at all the points, and they reported there's no problem. Everything is in compression. Now you have to be careful when you apply a displacement input in stiffness method formulation. You should know what you're doing. Number one. Number two, they could not model the reinforcement. So you have to have a clear understanding of macro level behavior. First, you must have a good intuitive understanding what's going on. You must be able to know, as a good structural engineer, what to expect. It's true even in frame analysis. When you get an output, say minus 180.53 kilonewton meter, you should ask many questions. First of all, minus, what does it mean? Is it sagging or hogging? What does your intuition say? Secondly, order of magnitude. Should it be 180? Should it be 18? Should it be 1.8? Or should it be 1800 or 18,000? Do you have a feel? So for that you have to have a good grasp. Computers kind of kill that sensitivity, because you have to use the computer only as a tool. You should be able to do design without computers. And that generation of engineers is dead. So for everything we use computers. For a statically determinate truss you use a computer, and the degree of indeterminacy can be 500. So you've got so many joints. But you must be able to check. The other problem we find is more serious. You may be having a shell. Recently we were helping someone design a helical staircase. I would have just put the whole thing as a beam and a space element and analyzed it. But they took a shell. You have to be careful when you take shells. Plain shell element. Then 180.53, is it kilonewton or is it kilonewton meter per meter? Everything matters. You have to have a good understanding of everything. But primarily your intuition has to be strong. That develops from practice, by making mistakes, by laughing at yourself. Hopefully they're only on paper. If you actually build structure, then they collapse, then be prepared to go to jail. Seriously. The job of a structural engineer is a serious job. It's like a surgeon. If the patient dies, you have to be responsible. So it's a very, very powerful, beautiful profession. Now you see the report on that bridge collapse in Kolkata, which came today. We knew there was a design flaw. And there was a construction flaw. Usually you have all flaws. There was a poor material usage flaw. So we are banking on factor of safety for everything. But factor of safety is often a factor of ignorance, we know. But you have to protect society, you have to protect organizations, you have to protect yourself. And do the right thing. If you did it honestly and it was a mistake, I think it's forgiven. But most often, you should be competent to solve the problem by yourself, and that competence is often in question. So,
Sir, I agree with your point that due to use of software, there is a lack of manual design. But manual design consumes more time. But at this point, everyone are looking at that project.
why are we in such a daring hurry? Where do you want to go, my friend?
The clients are requesting the design immediately after they once they produce the plans. Right?
So,
And due to that, nowadays we are using tools.
so you make blunders. So you produce expensive projects. You're right.
No, there is lack
Right
of
now,
knowledge.
we are sitting in a classroom. We are asking, is there a healthy way to practice? Is there an unhealthy way to practice? Unhealthy practice is always associated with greed. If I have set up a professional practice, and everybody says, go to him, he is the man to trust, even if he takes more time, people will still come to me, they won't come to you. Guarantee. Not only that, I charge more than you, still they'll come to me. Why? Because they trust me. That's the difference. But I agree with you, people are cutting and underbidding, and there's so much rivalry. So what do I say is, look, I need the time. I need the time. Because I need to really go through it. The macro concept, then I need to go through the detail. But if you're in such a tearing hurry, go to him at your risk. You understand what I'm saying?
Yeah, I understand.
So the whole modern lifestyle is unhealthy. We're going too fast at a mad pace, and thousands of mistakes creep in because of the sheer hurry. Everything is overlooked. Failures are bound to happen. Do you agree or not? So you have to change your whole philosophy of living. Be calm, be contented, be collected. That's a message I give to everyone. You may share it or not, that's left to you. But I can sleep well at night. And not only that, we also convey the right message. See, often you have to teach the clients. If you want to do this project well, you need a certain period for planning and design. You can't have it tomorrow. Some people want it yesterday. Don't come to me. I stand for high quality. You stand, your qualifications are different. Don't come to me. IIT can afford to say that. Still, we have a long line of people waiting. So it's left to you to decide what level you want to operate. But certainly, people with standards will not compromise. And why? I don't need that money. There's no greed. You understand? So, underneath all corruption, technical or otherwise, there is greed. Here you have abundance, and you want to help people who really want help. Are you getting the bigger picture? I'm glad you asked that question, though it is not shrinkage. Okay. So there are two kinds of shrinkage, especially important in reinforced concrete design. More important than autogenous shrinkage is drying shrinkage. But recently, autogenous shrinkage has made its appearance in codes, and the Priestess Concrete Code introduces this IS 1343 in the recent version. What does the word autogenous mean? Autogenous. Self, auto is self. Okay, self.
Little time without applying of any stress.
Self-generating. Self-generating. Gene, it's coming from within. How does it happen? Why does it come from within? So these are some, this is straight from the code. Develops during hardening of concrete. The major part develops in the early days of after casting. What is this? What is autogenous shrinkage? Why does it happen? Autogenous shrinkage is shrinkage that happens during the early phase of concrete hardening, not when you use it in a structure, in the early times. Why does it happen? It happens during the period of hydration of cement, okay, the hardening process. And cement particles are what? Are greedy for water. They're looking for where's the water? I want to hydrate, I want to hydrate. If you have a low water cement ratio, most of it gets consumed early, and then they're looking for water. And they're not able to find it readily. So what happens is, this creates a tension in the capillary pores. And that induces shrinkage, early shrinkage. Got it? That's the scientific explanation for autogenous shrinkage. If you want to minimize this shrinkage, what should you do? Simple solution. Huh? Provide water. How will you provide water? Curing. Well, keep the surface wet. Continuously wet or continually wet? What's the difference between continuous and continual? Very important words in English, no? Those words are very precise. I mean, what is the difference between continuous and continual? Continuous means non-stop, 24/7. Practically impossible. Why? So, in practice, you'll have to have breaks. But you don't forget, you come back and the break should be short. That is continual. Many practices in life can be only continual, though we would like it to be continuous. Got it? But that break is good enough. The moisture is still there. It's still, relative humidity is high in that. Don't think it needs directly water. Water vapor itself is good enough for hydration. Okay. Epsilon CA, that is autogenous shrinkage strain, is a linear function of concrete strength. So it depends on concrete strength, and this is based on empirical understanding. It varies with concrete strength. The higher the concrete strength, the more the shrinkage. Why? Because you got more cement paste, greedy for more water. It should be considered especially when new concrete is cast against hardened concrete, against old concrete. Because old concrete doesn't need this, new concrete needs it. So you have to do this. But the shrinkage that is really of significance, I mean, this pales into insignificance when you compare with this. And in the early days, we didn't even include this in our shrinkage calculation. This is really important, drying shrinkage. What is drying shrinkage? What's the difference between autogenous shrinkage and drying shrinkage? Fundamentally, autogenous shrinkage happens in the hardening phase. Drying shrinkage happens to hardened concrete over the lifetime of the structure. What is drying shrinkage? The water entrapped inside the concrete evaporates and goes out from within. So drying shrinkage strain, I think this should be D, epsilon CD, develops slowly as it is a function of migration of the water through the hardened concrete. Concrete shrinks in the hardened state due to the loss of moisture by evaporation. The consequent reduction in volume is termed as drying shrinkage. It's volume, it happens in all directions. It's not partial to the length direction, all directions. So total shrinkage is the sum of drying shrinkage and autogenous shrinkage. So let's just see how these can be modeled very quickly. So there's this formulation for autogenous shrinkage where you have an exponential function, 1 minus an exponential function. And we'll show you a graph, but typically this has some coefficients, and typically it has values like this, and the values are very small. Remember the value we looked at 0.003. That 0.003 is still there in IS 456, which has not been revised. 0.003. It actually is not telling the whole truth. If you had to build a structure in, say, Jaisalmer in Rajasthan, will you take a higher value or lower value? If you had to do it in a place like Kerala, where you rain all the time, will you take a lower value or higher? Well, don't take lower, at least 0.003. Not 3, but the code says that you play. But it can go 3-4 times that. Okay, so you have to understand it. But compared to that, this is very, very low. So actually, as a structural engineer, see, structural engineer, you have to know, not only structural, in everything in life. Don't be penny wise, pound foolish. What is penny wise, pound foolish? In management, they discuss like this. You have a meeting, board meeting, we are discussing projects, big money has to be spent, crores have to be spent. Then at the end, agenda item, they say, now you have to make your contribution for tea and biscuits. That's where the major, why should I pay 50 rupees? You've already signed off 50 crores, but that is public money. Your money, 50 rupees also you don't want to pay. So sometimes we nitpick over small things, missing out the big picture. Similarly here, this is really small. Compared to, because then that's where the 10 raised to minus 6 is gone to 1 million, but it increases with grade of concrete. Drying shrinkage also can be modeled. Please go through this. We will need to do these calculations when we especially consider loss in pre-stress. Here also parameters are there. You have TS, the age of concrete at the beginning of drying shrinkage. Normally, it's the end of the curing. Now, curing can be done in many ways. Usually, it's moist curing. In some countries, they don't cure at all. In Malaysia, I know people. What do they do? Because I don't know what to do. In France, do they pour water, or in Poland? So in India, you need to pay for labor. Of course, you can put jute cloth and keep it wet. That class of labor is called bishtiye. Their job is to pour water. In India, labor is. But even in Malaysia, they found that they want to save money. Not only people want to save time, they want to save money. So how do you avoid pouring water? Water has to be of good quality. What quality of water do you need? The same water which you drink, concrete must. Otherwise, what happens? You'll have all kinds of problems, chemical attacks. So water itself is costly. It's strange. When I was a student here, water was flowing everywhere. We drank it straight from the tap. Now water is as costly as milk. In drying shrinkage, what you want to prevent is escape of water from within the concrete. As long as water is trapped in the concrete, it's available for hydration. It doesn't dry, it doesn't shrink. And especially in the early period, even for autogenous shrinkage, you need water. So what you do is, you put a membrane on top of the concrete, or you spray a paint which prevents the escape. It's a cheaper solution, right? That's it. I don't add water, but I don't subtract water.
It's quality.
Quality of what?
There is a quality in the construction much higher than the curing part, or
quality.
Like it's much better than to.
Performance of the structure.
You're saying that is better than.
I'm asking.
I don't know. In India, we don't follow that practice, so I don't know. Quite honestly, I don't know because I need proof. So, but it seems those sprays are a little expensive. So yeah, the tried and tested method is to pour. In slabs, what do? They do ponding. That means you keep the water there, but the water will dry up, so you have to refill it.
Only one side is enough or both sides are
Concrete, is it partial to any one side?
the roof what will do bottom.
Moisture is something, you want the concrete to be wet. When you're in a shower and you pour water, does your whole body feel damp or only your head feels damp? If the front side of your shirt gets wet, does the wetness percolate to the... So you need H2O. H2O can come in many forms. Vapor is good enough. So if in the ambience you've got water vapor, that's good enough. So you don't need actual water. Okay. So you have also a function of H0. Remember the H0, the surface area to perimeter ratio. And so please go through this. I'll just show you some typical values. So this is unrestrained drying, free shrinkage. It's called free shrinkage. In 10 raised to minus 6. So it's one order of magnitude higher than you get for autogenous. So it's this high, and it's a function of H0. To understand this, and it's a function of the grade of concrete. So let's draw some graphs. These graphs are plotted. In fact, last year I requested the TA, Bijli, she drew these graphs, but you can check it out by using the same equation. So we've got both drying shrinkage and autogenous shrinkage on the y-axis, and we've got time after curing has stopped. Okay, T minus Ts is time in days after curing has stopped. And then you'll find that first of all, autogenous shrinkage is so small compared to drying shrinkage. You also find that, can you explain this? Why is it that if you have higher grade concrete, your drying shrinkage is less, but your autogenous shrinkage is more? Potential quiz question. Okay, I've already leaked out one answer, half the answer, the other half you have to figure out. Well, when you add up everything, you get this. You'll find both the effects cancel out, so it really becomes more or less independent of the grade of concrete. That's why we don't bother about grade of concrete, because though you get more for higher grade in one instance, you get less in the other instance, then you cancel. But the overall shape is like this, and it depends on the type of curing. Is it moist curing? Is it autoclave curing? Is it dry curing? You understand? So this is a typical gain shrinkage. So most of the shrinkage happens in the early stage. Just like creep, the graph is just like creep. And very little happens towards the end. Now we come to the next question.
The minimum number of days.
Minimum number of days? How shrinkage or curing, which word you curing? How many days should you cure?
How many days you have to water?
That's called curing. Curing. How many days should be cured? Shall I say the more the better is fine? Wait. More the better is good? Is the answer correct? More the better. Let's say you don't stop curing throughout the lifetime of the structure. Is it good or bad? Huh? Bad. Why? Huh? Is it good or bad for the concrete, not for the human beings occupying it? Is concrete happy when it gets water lifelong? Happy or not? Good or bad?
Bad.
Why?
Amount of time it reaches its maximum compressibility strength. After that,
It doesn't reach. Cement is waiting to get hydrated. Hydration never stops. Hydration never stops.
But then shrinkage will stop, sir. What?
It will not shrink, no? You bought a cotton shirt and you know it's going to shrink, but you do one thing. You keep it in water and never take it off. Don't wear it. It will not shrink. Taj Mahal, you know, that monument is suffering today. Do you know why? It's a structural problem. Why is the Taj Mahal in distress today? Why? Are Pollution.
Pollution.
That's a separate topic. This is structural engineering we're discussing. Why is Taj Mahal supposed to be in distress?
Erosion.
None of you. It has to do with the farm. Yeah.
Yamuna
Yamuna River
Erosion.
Drying up of
is drying up. Water is going away. But Taj Mahal is not happy. You may be happy because you think the water is doing harm. If the river is drying up, why should Taj Mahal be affected? Floating foundation. Why? It's a pontoon bridge, is it? What pipe? Well foundation. Well foundation. When who built Taj Mahal, by the way?
Shah Jahan.
Shah Jahan got it built.
Yeah. There were two architects, right?
Yeah.
One from Turkey, Ottoman Empire, and one from Persia, Iran today.
I'm not so sure. I thought it was done mostly by. It's a Mughal period, so they would have got help from others. But the labor was Indian labor, and you think they put concrete wells in there? No. Britishers came later. So what did they do? Sand. They drove trees into the ground. They were wooden pipes. Now, wood is happy when it is either completely dry or completely wet. But when you take away water from wood, then you have problems. You know that. That's a problem. So please study it. One of you can look into that. So water is good. Keeps everybody happy as long as but water is not available. That's a problem. Okay. This is a question, good question to ask. I have a simply supported beam. I just keep it there. We'll all keep it here. And we'll measure the deflection due to its self-weight. What's the deflection due to self-weight? Formula? Elastic deflection.
For simply supported,
Simply supported.
uniform distributed, or
Self-weight, I said.
Self-weight.
What uniform distributed? Huh? Your memory is very full, but you didn't finish it.
WL4 by EI.
WL4
By
by
EI.
EI. Very good. Let me just trouble you with a tricky question. Let's say I remove half the load from one half. Then will the deflection at midspan will also become half? Yes? How many people agree with that? Become 2.5 by 384 into WL raised to 4. Because I removed half the load at midspan, will it also become half? Yes or no? Yes? How many people say no? Why yes? Can you prove?
Superposition, like constraint outward.
Okay. So explore. I've discussed this in my book, Instructional Analysis. I'm happy to hear these answers, but did you read the book or you knew it? Wonderful. You have to apply the principle of parity and the principle of superposition. Okay, good. Let's come back to this question. Now we visit. We keep recording the deflection continually, not continuously. You understand? Continually. That means every day we measure. and we do it over a long period, how long shall we do it? Till we grow old. 50 years we'll do it. And somebody will do it. The IIT, you have enough people. Some student will keep measuring over 50 years. Will the deflection increase? Due to shrinkage. Drying shrinkage. Yes, says the court, because court wants you to check for long-term deflection. You will also get an increase in deflection due to creep, because you have sustained growth. But due to shrinkage, now a simple question, let it shrink, why should it deflect? Did you not study this in BTech, that long-term deflection due to shrinkage? Yes or no? Studied or not? Didn't study. Nobody. Okay, now you study. You tell me why is the court demanding this? Anybody? Concrete is there. Volume shrinkage takes place. Let it shrink. What's the problem? Why will deflection increase?
I decrease.
Huh?
I decreases.
I decreases. How much will it decrease? You will find, no, if you work it out, the reduction in the I value is so insignificant. Even if you calculate reflections, are much, much more. He's saying EI, no, that I will decrease because of this 0.0003 reduction in B and D. Is that BD cubed by 12? No, that's not negligible. You should know what is significant, what is insignificant. Insignificant, don't waste your time. I'll give you a clue. If it's plain concrete, it won't happen.
As we discussed, for creep, the strain will be transferred to steel.
If it's plain concrete, the reflection will not be. If it's doubly reinforced with equal reinforcement at top and bottom, it will not increase. If it is singly reinforced with steel only at the bottom, then only you will have deflection. Why? I've given you, I've linked out. So, it is caused by differential shrinkage. What will happen due to differential shrinkage? There will be curvature. You're right. Well said. So this is our beam. We've got steel. Let's say the hanger bars is negligible. We'll ignore that. It deflects like this. Why? Well, you find the steel doesn't want to shrink. The concrete wants to shrink. The top surface is free to shrink. And so, let's see, shrinkage. So you get a curvature. Right? Top shrink. So you get a curvature, and the curvature is approximately given by this difference in what happened at the level of the steel and at the top level. And so automatically it will take that shape. Right? The bottom doesn't want to shrink, the top is free to shrink. So you have even a formula for shrinkage curvature. Please use the same symbol for curvature. In a cantilever also the same thing happens. You have steel at the top, it will increase. You figure out why it happens in a cantilever. I've given the clue. Now last topic is temperature difference. What kind of temperature problems you have to worry about as an engineer? Especially in today's times, when do you have to worry about temperature? Fire, okay, fire is a big issue. But fire, to protect your building against fire, what should you do? What should you do? There's a fire rating. National Building Code demands you satisfy that fire rating. So, in spite of that, if there's a fire, you have to watch out. So, in concrete, fire is taken care of how? In reinforced concrete, in beams, columns, slabs. How?
Providing a much bigger cover.
By providing the desired cover to achieve the fire rating. Okay. But in spite of that, if there's a fire, concrete can handle fire pretty well. And steel, if it's protected, can handle it. So we are not talking about that. For a designer, you don't have to do anything extra for fire once you've given enough cover and protection. If you're doing a steel building, you have to clad it, give it a protection. But we're doing reinforced concrete, don't have to worry. But temperature, why do you have to worry?
Sir, if summer you have plus 38 and winters you have minus 20, won't be a problem.
Sorry?
If in summers we have plus 38, maximum 40, and in winters we have minus 20 in average, there is a problem, right? For
That's
that?
the problem. But you don't have to go to minus 20. Whenever you have a seasonal variation in temperature. What's the seasonal variation of temperature in Chennai? Give me the degrees. 20 degrees what? Fahrenheit? You always finish your sentence. Celsius. 20, 25 is global warming, no? The up thing is going up. Delhi? Delhi it can touch 0. 45. Poland?
We have plus 42 maximum.
Huh?
We have.
Just tell me the variation.
Well, we have even
France?
Sir, minus 32 plus 40 we have.
Look at that. 70. You?
Minus 5 to
13. No, in France also.
10,000.
I remember there was a heat wave and a lot of people suffered. I think people died also.
Yeah.
Yeah, so global warming can change everything now. You need high weather. Minus 30 in Poland? A little
Romania, sir.
Huh?
Romania.
Sorry, in Romania.
It was minus 32 actually.
32.
Yeah, I couldn't walk outside.
Celsius of?
Celsius, sir.
Sure.
Very sure.
Minus 32. Which place?
And north of Romania,
Oh,
at the
yeah.
border with Ukraine.
Okay.
That's why I have like Russian accent. Like,
Okay.
it's very cold over there.
So you have the mountains there.
Yeah.
That is one, but the rest of Romania, I hope is
Same.
Huh?
No, that's minus 25, not minus 32.
So you better learn this subject very well.
Yeah.
So, what will happen to the building?
We manage.
How do you manage reinforced concrete? That means you don't have to worry about the design. How do you manage?
Well, in my BTEC we had like the cycles, how many cycles we have. And it's something in the recipe of concrete, how they design it.
Well, usually you're right, concrete is durable, it can handle that variation. But the problem comes when it's a function of the size of the structure. Okay, if your structure is long in one direction, then you have to worry about it, right? And we have to give what are called joints, which relieve the temperature effect. They're typically called expansion joints. In the Indian code, the recommendation is if the length in any direction exceeds 45 meters, what should you do? It's desirable to provide an expansion joint. If you don't provide an expansion joint, you should do a thermal analysis and put additional reinforcement wherever required. The problem is many people don't know how to do thermal analysis. If you do thermal analysis, let's take a simple beam. And let's say the two ends are restrained. And you have a change in temperature of 70 degrees Celsius. And let's take the worst case, that means you cast it in the hot summer and you are now in winter, so it's actually reduced in temperature, so there will be actual tension. How much will be the actual tension? What will be the actual tension? Normally beams you don't design for actual tension, but this beam will have actual tension. How much will it be? Quickly, tutorial problem. You're going to get a tutorial next week or the week after that.
The
Yeah.
formation is ATL. ATL, the coefficient of thermal expansion.
Okay.
Variation.
Let's say alpha is given to you, then
Alpha T.
alpha T. So you can work out. And then you get the change in length, L alpha T, or the strain is alpha T. From the strain, how do you get the force? Well, you know the axial stiffness is EA by L, you can work it out, right? It's a huge force. You'll end up pumping steel. So it's actually a little funny that engineers think that, so they stop the building at 45 meters and think that I don't have to worry. Of course you have to worry. Challenge is that once a concrete cracks, its stiffness degrades. And so the tension will come. So it's a deformation-induced tension. Can I spill over for a few minutes? I want to finish this now. Stress is due to thermal gradient as in roof slabs. Air-conditioned roof. So you have seasonal variation in temperatures, then you have temperature gradient during any season also. For example, air-conditioned room, hot summer, you've got slab, you get curvature due to that. Exposed to sun or in chimneys. Okay, here's a question. In a chimney, you've got a hot gas inside, you've got a thermal gradient. Where will you put your steel? Inside, close to the inner circumference, or close to the outer circumference? Outer circumference. Why? Outer circumference wants to increase in circumference. Inner circumference wants to also increase in circumference, but the shell is not very thick. The diameter is huge. Diameter could be 30 meters. The shell could be 600 mm. So inside wants to expand more, outside wants to expand less. Where will you get tension more? Inside or outside? Think about it. Think about it. Because you have to judiciously put the steel in the right place. Wherever. Think about it. I won't leave. Okay, so go through this. Many structures, temperature loads need to be specially considered. Seasonal variation in temperature, etc. In general, it is good design practice to provide some nominal reinforcement in concrete at locations where cracks can potentially develop due to the effects of temperature shrinkage, especially in large members. That's where you have a minimum percentage reinforcement. You have a coefficient of thermal expansion which can vary from 6 to 12. Concrete is more or less, steel is more or less similar to concrete. With that, we complete this topic. So in the next class I will take up this, and losses and pre-stress I'm going to postpone to teach along with pre-stress concrete. This topic will be taken by Professor Radhakrishnan Pillai in the next class. So I cover this in this on Friday. Thank you.